July 1st, 2025. Somewhere above the Earth, a telescope blinked and caught something moving. Not a satellite, not a star. Something drifting through the constellation Aquarius, faint and far away, traveling through the dark like it had been doing so for longer than we could imagine. The astronomers who spotted it didn't panic. They didn't celebrate. They just watched. Because they'd seen this before. Twice, actually. They called it 3-Eye Atlas, the third confirmed interstellar visitor to our solar system. The third object we've ever found that didn't come from here. That wasn't born around our sun. That crossed the void between stars and somehow ended up in our neighborhood. The first one was Oumuamua. Strange. Elongated. Silent. It appeared in 2017, confused everyone, and then left before we could figure out what it really was. The second was Borisov. A comet. Normal. Almost boring. It came, it glowed, it left. And honestly, that was a relief. Because after Oumuamua, scientists needed something that made sense. So when 3-Eye Atlas showed up in the summer of 2025, most astronomers assumed it would be like Borisov. Just another icy traveler from another star system, passing through on its way to nowhere in particular. At first, everything looked ordinary. The orbit calculations came back clean. Hyperbolic trajectory. That meant it wasn't bound to our sun. It was moving too fast, heading in from somewhere beyond the edges of our solar system, bent around the sun like a whip crack, and then it would be gone. Simple, predictable, forgettable. The early images showed a faint smudge, nothing dramatic, just a dot moving slowly against the backdrop of distant stars, shifting its position night after night. You could barely tell it was there unless you knew where to look. Scientists logged it, cataloged it, calculated where it had been and where it was going. And for a few weeks, that was it. Another footnote in the growing list of interstellar objects humanity had finally started to detect. But then, something changed. As 3-Eye Atlas moved deeper into the solar system, as it got closer to the sun's warmth, astronomers started refining their observations. Better data, clearer images, more precise measurements, and that's when they noticed the trajectory wasn't quite as random as it seemed. It wasn't just drifting past us, it was aiming. The numbers didn't lie. Every new calculation pointed to the same conclusion. 3-Eye Atlas wasn't heading toward some random point in space. It was heading toward Jupiter, the largest planet in our solar system. The king of storms, the gravitational giant that shapes everything around it, and it was going to pass close, really close. Close enough that some scientists started doing the math twice, then 3 times, because the odds of an interstellar object randomly arriving at our solar system and aligning its path so precisely with Jupiter's location? Less than 1 in 2,000. That's not impossible. Rare thing. Happen. But it's rare enough that people start asking questions. Uncomfortable questions. Questions like, could this be intentional? Most scientists shook their heads. No, of course not. It's just a comet. A chunk of ice and rock from another star system following the mindless mathematics of gravity. Nothing more. But very few, kept those questions to themselves and kept watching. They felt because 3-Eye Atlas was still months away from its closest approach to the sun. And comets? Comets change when they get close to heat. They wake up. They become active. They release gas and dust, developing glowing halos and brilliant tails that stretch for millions of kilometers. If 3-Eye Atlas was going to do something strange, something that didn't fit the models, this was when it would happen. So observatories around the world prepared their instruments. Schedules were cleared. Observation time was allocated. Teams coordinated across continents to make sure someone, somewhere, would always have eyes on this visitor. They expected a show. A beautiful, normal, predictable show. What they got instead was something no one saw coming. Because as summer turned to autumn, as 3-Eye Atlas closed in on the sun, creeping toward that critical moment when heat and radiation would transform it from a dark, silent traveler into an active, glowing comet, the astronomers started noticing things that didn't add up. Small things at first, subtle, easy to dismiss as measurement error or atmospheric interference, but the things kept adding up, and the errors weren't errors. By late October, when 3-Eye Atlas reached its closest point to the sun, when every major telescope on Earth turned to capture the moment, they realized they weren't just watching a comet anymore. They were watching something else entirely, and the data that came back from that first observation changed everything. October 28th, 2025. The day arrived. Perihelion, the moment 3-Eye Atlas would pass closest to the sun, diving to within 1.4 astronomical units, just inside the orbit of Mars. This was supposed to be the moment, the fireworks, the grand reveal, because this is what comets do when they get close to the sun. They come alive. The heat hits them. The frozen surface, ice that's been locked in place for millions, maybe billions of years, starts to crack. Water vapor erupts in jets. Carbon dioxide boils off. Dust particles, trapped in the ice since the comet first formed, suddenly break free and stream away, pushed by the pressure of sunlight. The comet develops a coma, a glowing fuzzy cloud of gas and dust that surrounds the solid core, expanding outward for thousands of kilometers. And if conditions are right, if the comet is active enough, a tail form. A brilliant, sweeping banner that points away from the sun, sometimes stretching for millions of kilometers across space, visible even from Earth. Beautiful, unmistakable. This is the script. This is what happened. Every time. So when Observatories across the planet turned their instruments toward 3i Atlas on October 28th. They expected to see exactly that. A burst of activity, a brightening, the birth of a tail. They expected the comet to announce itself. Instead, it went quiet. At first, no one believed the data. The telescopes were working fine. The atmospheric conditions were clear. The tracking was accurate. But the images coming back showed something that didn't make sense. 3i Atlas was dim. Not just a little dim. Not less active than expected dim. Silent dim. There was no expanding coma. No jets of gas shooting out from the surface. No dust tail streaming away from the sun. The object just sat there. A dark, quiet dot. Barely brighter than it had been weeks earlier when it was still far from the sun's heat. One astronomer in Chile checked the data 3 times before calling his supervisor. Another team in Australia thought their instruments had failed. They recalibrated everything, ran diagnostics. The instruments were fine. A researcher in Hawaii stared at her screen and whispered the same question everyone was thinking. Where's the activity? Comets at this distance, this close to the sun, should be erupting. The solar radiation should be tearing material off the surface. Even a small, quiet comet would show something. A faint glow, a hint of a tail. Anything. But 3i Atlas gave them nothing. It was as if the comet had turned itself off. Or maybe it had never been on. The silence was unnerving. Because silence in astronomy usually means something is dead, old, depleted. A comet that's made too many passes near a star, lost all its volatiles, crusted over with inert rock and dust until nothing's left to boil away. But 3i Atlas was an interstellar object. It had never been near our sun before. This should have been its first awakening, its first breath of heat in millions of years. So why wasn't it waking up? The data started circulating through private channels, emails, encrypted messages, conference calls with colleagues on the other side of the world, whispering the same disbelief. Are you seeing this? It's not outgassing. It should be active. Why isn't it active? Some scientists suggested the comet might be covered in a thick crust, an insulating layer of dust and rock that prevented the ice underneath from heating up quickly. That's possible. It's happened before with other comets, but even crusted comets show some activity at perihelion. Cracks form. Weak spots break open. Something escapes. 3i Atlas showed nothing. Others proposed that maybe the comet was made of different materials. Maybe interstellar comets don't behave like the ones in our solar system. Maybe they form under colder conditions, with less volatile ice, more stable rock. That was possible too. We'd only studied 3 interstellar objects. We didn't know what normal was for them yet, but the silence still felt wrong. And then, 48 hours after perihelion, the second observation came in, and that's when everything changed. Because 3i Atlas wasn't just quiet, it was doing something. The light reflecting off its surface wasn't steady, it wasn't random, it was pulsing, rhythmic, regular, repeating every 11.3 seconds. Like a heartbeat, like a signal, like something turning on and off with mechanical precision. And across 3 continents and observatories that had never spoken to each other before, astronomers sat in the dark, staring at the same impossible data, asking the same impossible question. What are we looking at? Retry November 1st, 2025. 2 days after perihelion. 2 days after the silence that confused everyone. And that's when the reports started coming in. Not from one observatory, not from one team, but from multiple sites across the planet, all seeing the same thing at the same time. It started in Chile, the Atacama Desert, one of the driest, clearest places on Earth, where the stars look so close you feel like you could touch them, where some of the world's most powerful telescopes sit on mountaintops, watching the universe with mechanical patience. An astronomer named Dr. Elena Vargas was reviewing the latest images of 3i Atlas when she noticed something odd in the data stream. The brightness wasn't stable. She frowned, leaned closer to her screen, ran the photometry analysis again. The object was flickering, not randomly, not like a comet tumbling through space, catching sunlight at different angles as it spins. That kind of flickering is chaotic, unpredictable, messy. This was different. This was regular. She watched the light curve graph on her monitor, a line tracing the brightness of 3i Atlas over time. And every 11.3 seconds, the line dipped, then rose, then dipped again, like clockwork, like a pulse. She thought it was an error. A glitch in the software, maybe interference from a satellite, maybe atmospheric turbulence messing with the measurements. So she called her colleague. Hey, can you check something for me? Run the photometry on 3i Atlas again. Tell me what you see. 5 minutes later, her colleague called back. His voice was quiet, confused. Elena, I'm seeing it too. That's when she realized this wasn't an error. 30 minutes later, she sent an encrypted email to 3 other observatories. One in Australia, one in Hawaii, one in South Africa. The subject line was simple. Are you seeing this? The responses came back within hours. Australia. Yes, every 11.3 seconds, confirmed. Hawaii. We thought our instruments were malfunctioning. It's real. South Africa. This doesn't make sense, but yes, we see it. By the end of the day, the data was undeniable. 3i Atlas wasn't just reflecting sunlight, it was pulsing, brightening and dimming in a rhythm so precise you could set a clock to it. 11.3 seconds. Flash. Dim. Flash. Dim. Over and over and over. And the scary part? It was synchronized across every observation, no matter where you were on Earth. No matter what telescope you used, the pulses lined up perfectly. That's not natural. When a comet tumbles through space, it rotates irregularly. It's unbalanced, shaped like a potato or a peanut, not a perfect sphere. So when sunlight hits it, the brightness changes at random intervals. Sometimes fast, sometimes slow, never predictable. But 3i Atlas was predictable. Perfectly predictable. The kind of precision you see in machines, in satellites, in things designed to repeat a function over and over without deviation. Not in rocks, not in chunks of ice drifting through space for millions of years. The first theory was rotation. Maybe the comet was spinning in a way that created this effect. Maybe one side was brighter than the other, and as it rotated, we saw the bright side, then the dark side, then the bright side again. But rotation doesn't work like that. Not with this kind of precision. Objects in space don't spin at perfectly stable rates. They wobble. They precess. Gravitational forces, solar wind, outgassing jets, all of these things affect how fast something spins. And over time, the rotation changes. But 3i Atlas's pulses didn't change. 11.3 seconds. Every time. For days. No variation, no drift, no wobble. The second theory was outgassing. Maybe jets of gas were firing from the surface in timed bursts, creating a strobe effect as material erupted and then stopped, erupted and stopped. But the comet wasn't outgassing. Remember? It was silent. No jets, no coma, no tail. So where was the light coming from? That's the question that haunted Dr. Vargas. That's the question that kept her awake at night, staring at the ceiling, replaying the data in her mind. Because the only explanation left was the one no one wanted to say out loud. What if the pulses weren't natural? What if something inside 3i Atlas was creating them? What if the object wasn't just reflecting light, but controlling it? The word started spreading quietly through the astronomy community. Not in press releases, not in public statements, but in private emails, in late-night phone calls, in messages marked confidential. Have you seen the light curve? It's pulsing, every 11.3 seconds. What does that mean? Some scientists dismissed it immediately. Coincidence, instrument error, a natural phenomenon we just didn't understand yet, but others weren't so sure, because they'd seen something like this before. In 2017, when Oumuamua passed through our solar system, it also showed strange accelerations, movements that couldn't be explained by gravity alone. Like something was pushing it, steering it. The mainstream explanation was outgassing. Invisible jets of gas creating thrust. But some scientists, including Dr. Avi Loeb from Harvard, suggested a different explanation. Maybe Oumuamua wasn't natural. Maybe it was a light sail. A thin sheet of material designed to catch sunlight and use it for propulsion. Maybe it was a probe, sent by someone, from somewhere. The idea was controversial. Most astronomers rejected it, but the question never really went away. And now, 8 years later, here was another interstellar object doing something it wasn't supposed to do. Pulsing, signaling, acting like it had a purpose. Dr. Vargas sat in her office at 2 a.m., staring at the light curve on her screen. The rhythmic rise and fall of brightness, the perfect mechanical precision, and she asked herself the question that was becoming impossible to ignore. What if this isn't a comet? She didn't say it out loud. Not yet. Because once you say something like that, you can't take it back. Once you suggest that an object from another star system might be artificial, you cross a line. You become the person who believes in UFOs, in alien probes, in things that sound like science fiction. But the data didn't care about her reputation. The data didn't care about what was supposed to be possible. The data just was. 11.3 seconds. Flash. Dim. Flash. Dim. Like a heartbeat. Like a message. Like something trying to be seen. And somewhere, deep in the cold machinery of 3i Atlas, something continued to pull, over and over, without stopping, without changing, as if it was waiting for someone to notice, as if it wanted to be found. November 8th, 2025. 1 week after the pulses were discovered, and that's when the second anomaly appeared. This time it wasn't visible light. It wasn't something you could see with a normal telescope. This time, it was heat. Infrared observatories around the world had been tracking 3i Atlas since its discovery, measuring the thermal emissions radiating from its surface. This is standard procedure for comets. You measure how much heat they absorb from the sun and how much they release back into space. It's simple physics, predictable, boring even. An object gets hit by sunlight. It heats up. Then when it's no longer in direct sunlight, it cools down. The temperature curve follows a smooth, logical pattern based on distance from the sun, surface composition, and rotation rate. Every comet we've ever studied follows this pattern. Every asteroid, every rock floating in space, until 3i Atlas. The first warning came from a team at the Very Large Telescope in Chile. They were running routine thermal imaging when the data started showing inconsistencies. The temperature of 3i Atlas wasn't behaving the way it should. At perihelion, when the comet was closest to the sun, soaking in maximum solar radiation, the surface temperature should have spiked. Fast, dramatic, hot, but it didn't. Instead, 3i Atlas stayed cool. Cooler than it had any right to be. It was absorbing energy, but not heating up. One of the researchers, Dr. Amara Osei, thought there was a mistake in the calibration. She ran the analysis again. Same result. She checked the telescope alignment, verified the atmospheric corrections, ran diagnostics on every piece of equipment involved. Everything was working perfectly. The data was real. 3i Atlas was absorbing sunlight and somehow not getting as hot as it should. That's impossible. she muttered to her screen. Where's the heat going? But it got stranger. A few days later, as 3i Atlas moved away from the sun, heading back out toward the outer solar system, the temperature curve should have dropped. Gradually, steadily, as the object cooled in the shadow of space. But it didn't drop. Instead, it stayed warm, warmer than it should have been, like something inside the object was generating heat, releasing it slowly, keeping the surface temperature stable even as solar radiation decreased. Dr. Osi stared at the graph on her monitor. The temperature curve looked wrong, unnatural. It wasn't the smooth, predictable rise and fall of a rock, heating and cooling in sunlight. It was controlled, regulated, like a thermostat. She sent the data to colleagues. Within 24 hours, other observatories confirmed it. The same pattern, the same impossible thermal behavior. 3i Atlas was heating and cooling in ways that violated every model of comet thermodynamics. It's absorbing energy when it should be releasing it, one physicist wrote in a group email, and releasing energy when it should be cold. This doesn't fit any natural process, I know. Some scientists tried to explain it without gassing. Maybe jets of gas escaping from the interior were carrying heat away from the surface during perihelion, keeping it cool, and maybe those same jets were releasing stored thermal energy later, keeping it warm. But there were no jets, no visible outgassing, no coma, no tail. The comet was silent. And yet, it was regulating its temperature like something alive. That word started appearing in private discussions, quietly, nervously, alive, not literally, of course. No one was suggesting 3i Atlas was a living organism, but the thermal curve looked less like geology, and more like biology. Living things regulate their temperature. They absorb energy when they need it, store it, release it when conditions change. They maintain internal stability even when the external environment fluctuates. That's called homeostasis, and 3i Atlas was doing exactly that. Dr. Ose ran simulations trying to recreate the thermal behavior using natural processes, rotating ice, subsurface insulation, exotic materials with unusual heat capacities. None of the models worked. Every natural explanation required conditions that were either impossibly rare or physically implausible. But there was one model that fit, one scenario that explained everything. If 3i Atlas had an internal energy source, something generating heat from within, something that could be turned on or off, regulated, controlled, then the thermal curve made perfect sense. But comets don't have internal energy sources. Machines do. Dr. Osi didn't write that in her report. She couldn't. It was too far outside the boundaries of acceptable scientific hypothesis. But late at night, alone in her office, she pulled up the thermal data again, stared at the graph, the smooth controlled temperature regulation, and she wondered, what if this object wasn't passive? What if it wasn't just drifting through space, subject to the whims of solar radiation and orbital mechanics? What if it was managing itself, absorbing energy when it needed to, releasing it when it didn't, maintaining stability, maintaining function, like something designed, like something with a purpose? She thought about the pulses, the 11.3-second rhythm that had been confirmed across multiple observatories, and now this. Heat regulation that looked more like engineering than geology. Two anomalies, both impossible, both pointing in the same uncomfortable direction. By mid-November, a small group of astronomers had begun coordinating in secret, sharing data, comparing observations, asking questions they didn't dare ask in public. What if 3i Atlas isn't natural? What if it's been designed? What if something sent it here? They didn't have answers, not yet, but the data kept coming, and every new observation made the natural explanations harder to believe. 3i Atlas continued its journey through the solar system. Silent, pulsing, regulating, heading toward Jupiter. And whatever it wasn't finished yet. November 15th, 2025. By now, 3i Atlas had everyone's attention. Not just astronomers, not just scientists, but space agencies, government observatories, private research institutions. Anyone with a telescope powerful enough to see it was pointing their instruments at this strange visitor from beyond our solar system, because something was wrong with it. Multiple things, actually. The pulses, the heat regulation, the silence when it should have been screaming. But what came next? What they found when they looked closer at the dust surrounding 3i Atlas? That's when the last threads of natural explanation started to unravel. It started with a single image. The Hubble Space Telescope, still orbiting Earth after decades of service, turned its lens toward 3i Atlas. High-resolution imaging, the kind of detail that can pick out features invisible to ground-based telescopes. The goal was simple: map the coma, the cloud of dust and gas that should be forming around the comet now that it had passed perihelion. Every comet develops a coma when it gets close to the sun. The ice heats up, material boils off, dust escapes, and all of that material spreads out in a rough, chaotic halo around the nucleus. It's messy, random, like smoke billowing from a fire, spreading in every direction with no order, no structure. That's what they expected to see around 3i Atlas. That's not what they found. Dr. Kenji Tanaka, an astrophysicist at the Japan Aerospace Exploration Agency, was the first to process the Hubble image. He loaded it onto his screen, adjusted the contrast to bring out faint details, and then stopped. He stared, blinked, zoomed in. That's not right, he whispered. The coma around 3i Atlas wasn't chaotic. It was organized. Instead of a random cloud of dust spreading evenly in all directions, the material formed patterns, geometric patterns, arcs, spirals, segments that repeated with unnatural symmetry. It looked less like a natural dust cloud and more like a diagram, a blueprint, something drawn with intention. Dr. Tanaka called his colleague over. "Look at this. Tell me what you see." His colleague leaned in, squinting at the screen. Then his face went pale. "Is that structure?" "Yeah," Dr. Tanaka said quietly. "That's structure." They ran the image through multiple filters, checked for artifacts, verified the calibration, confirmed the data was clean. It was clean, the patterns were real. Within hours, the image was shared with observatories around the world, and every team that looked at it saw the same thing. The dust around 3I Atlas was forming shapes, precise, repeating shapes. Not random, not chaotic, geometric. Scientists immediately tried to explain it, because that's what scientists do. They find natural explanations for things that look unnatural. The first theory was magnetic fields. Maybe 3I Atlas had a magnetic field, and the dust particles, which can be magnetic if they contain iron, were aligning along the field lines, creating patterns. But comets don't have magnetic fields. Not strong ones anyway. And even if they did, the patterns wouldn't look like this. Magnetic field lines create smooth, flowing curves, not sharp arcs. Not repeating segments. The second theory was rotation. Maybe the comet was spinning in a complex way, and jets of dust were firing from specific points on the surface, creating spiral patterns as the object rotated. But there were no jets. Remember? No visible outgassing. No active vents. The comet was silent. So where was the dust coming from? And why was it forming patterns that looked designed? Dr. Tanaka spent days running simulations, trying to recreate the geometry using natural processes. He modeled rotation, he modeled pressure, he modeled solar-wind interactions. He modeled every physical mechanism he could think of. None of them produced the patterns he was seeing in the Hubble image. None of them came close. One evening, exhausted and frustrated, he sat back in his chair and just stared at the image, at the arcs and spirals, at the repeating symmetry, and he thought about something he'd learned in college, a principle called Occam's razor. When you have multiple explanations for something, the simplest one is usually correct. So what was the simplest explanation for geometric patterns in dust? Something created them. Not gravity, not magnetic fields, not random chance, something deliberate. He didn't write that in his report. He couldn't. It was too dangerous, too far outside the boundaries of mainstream science, but he couldn't stop thinking it. The patterns looked artificial, like something had arranged the dust, shaped it, controlled its distribution, like something inside 3I Atlas was building something, or communicating something. Other scientists noticed the same thing. They didn't say it out loud. Not in official papers, not in public statements, but in private emails, in encrypted messages, in late-night phone calls. The question kept coming up. What if this isn't natural? What if the geometry is intentional? What if we're looking at design? By late November, the geometric patterns had been confirmed by multiple independent observations. Different telescopes, different teams, all seeing the same impossible structure in the dust cloud, and the patterns were evolving. Slowly, subtly, but changing. New arcs appeared. Old spirals shifted. The segments rearranged themselves over the course of days, forming new configurations, like something adjusting, adapting, responding. Dr. Tanaka watched the time-lapse images on his screen. Dust moving in patterns that shouldn't exist, geometry that looked less like physics and more like engineering. He thought about the pulses, the heat regulation, and now this. 3 anomalies, all pointing in the same direction, all suggesting that 3I Atlas wasn't just a rock. It was something else, something that had traveled across light years of empty space, something that had aimed itself at Jupiter with impossible precision, something that pulsed with mechanical rhythm and regulated its own temperature and arranged dust in geometric patterns, something that looked more and more like it had been made. He closed his laptop, sat in the dark of his office, and wondered, what are we looking at, and what does it want? The dust continued to spiral. The patterns continued to evolve, and 3I Atlas continued its journey toward Jupiter, silent, pulsing, geometric, waiting. November 22nd, 2025. The data that arrived that morning changed everything. Not because it was unexpected. Scientists had been running spectroscopic analysis on 3I Atlas for weeks, breaking down the light reflecting off its surface to identify what chemicals were present. This is routine work in astronomy. You point a spectrograph at an object, split its light into a rainbow of wavelengths, and look for the dark lines where specific elements absorb light. Every element has a unique signature, a fingerprint written in wavelengths. Iron shows up here, nickel shows up there, water vapor, carbon dioxide, silicate dust. You read the spectrum like a recipe, and from that recipe you figure out what the object is made of. Comets have predictable recipes: water ice, carbon dioxide, a little methane, dust particles containing iron, magnesium, silicon, trace amounts of other metals. We've analyzed hundreds of comets, thousands of asteroids, meteorites, samples from the Moon and Mars. We know what space rocks are made of. So when Dr. Yuki Nakamura, a spectroscopist at the Subaru telescope in Hawaii, loaded the latest data from 3I Atlas onto her screen, she expected to see a normal comet. Signature. What she saw instead made her breath catch. Nickel. A lot of nickel. More nickel than she'd ever seen in any astronomical spectrum. More nickel than should be possible in a natural object. She ran the analysis again, checked the calibration, verified the data reduction pipeline. Same result. The spectrum showed nickel emission lines that were 50 times stronger than any known comet. 50 times. That's not a little unusual. That's impossible. But it got worse, because where there's nickel, there should be iron. Always. In every comet we've ever studied. In every asteroid. In every meteorite that's ever fallen to Earth. Nickel and iron appear together. They're forged together in the cores of dying stars. They condense together when planets form. They stay together. The ratio is consistent across the solar system. Across the universe, actually. Roughly 10 parts iron to 1 part nickel. Sometimes more iron, sometimes less. But they're always together. Always. Except in 3I Atlas. Dr. Nakamura scanned the spectrum for iron lines. The characteristic wavelengths where iron should show up. They were barely there. Almost absent. The nickel to iron ratio wasn't 10.1. It wasn't even 1.1. It was inverted. Flipped. Wrong. There was 50 times more nickel than there should be, and almost no iron. She sat back from her screen. Felt her heart pounding. Because this ratio doesn't exist in nature. Not in our solar system. Not in meteorites. Not in the interstellar medium. Nowhere. She pulled up reference spectra from every comet catalog she had access to. Compared them to 3I Atlas. Nothing matched. She searched for research papers on nickel-rich asteroids, on unusual metal ratios in space, on exotic formation environments that might produce this kind of chemistry. Nothing came close. The only place humans see this kind of metal separation is in laboratories, in refineries, in industrial processes where metals are deliberately separated, purified, concentrated. Nickel is extracted from ore using heat and chemistry. It's separated from iron through processes that don't occur naturally in space. The universe doesn't refine metals. Humans do. Dr. Nakamura's hands were shaking as she wrote the email. She sent it to 3 colleagues she trusted. Subject line, "You need to see this." The responses came back within the hour. "This can't be real. Check your calibration. Where's the iron?" She replied, "Calibration is clean. Data is verified. I've checked everything 3 times. The iron just isn't there." By the next morning, 5 other observatories had independently confirmed the spectroscopic data. The nickel to iron ratio in 3I Atlas was impossible. And that's when the scientific community started to fracture. Some researchers doubled down on natural explanations. Maybe 3I Atlas formed in an environment with unusual stellar composition. Maybe it came from a system where the parent star produced more nickel than usual during nucleosynthesis. Maybe, possibly, theoretically. But the explanations required increasingly exotic scenarios, unlikely conditions, special circumstances that had never been observed anywhere in the universe. Other scientists started asking different questions. Quieter questions, dangerous questions. What if the metal ratio isn't natural? What if it's been processed? What if something refined it? One researcher, a chemist who'd worked on materials science for spacecraft, sent a private message to Dr. Nakamura. "If I wanted to build something that needed pure nickel, something that couldn't have iron contamination, this is what the spectrum would look like." Dr. Nakamura stared at that message for a long time. If I wanted to build something. Not if nature created something. If I wanted to build something. The implications were staggering. Because if 3I Atlas contained refined metals, then something had refined them. And refinement requires technology, purpose, intelligence. It requires someone or something making a choice. She thought about everything else they'd discovered. The pulses, the heat regulation, the geometric dust patterns, and now this. Chemistry that looked less like a comet and more like engineering. She opened a new document, started writing, then stopped. Because once she wrote this down, once she suggested what the data was implying, there was no going back. Her career, her reputation, everything she'd worked for. But the numbers didn't care about her career. The numbers were what they were, and they were telling a story that was becoming impossible to ignore. 3I Atlas wasn't just unusual. It wasn't just exotic. It was refined, processed, built with chemistry that doesn't happen by accident. She looked at the spectrum on her screen one more time. The blazing nickel lines, the absent iron, and she asked herself the question everyone was thinking, but no one dared to say, what if this isn't a comet at all? What if it's a machine? The data sat on servers around the world, encrypted, classified, shared only among a small group of scientists who'd signed confidentiality agreements. And 3I Atlas continued its journey, toward Jupiter, carrying its impossible chemistry, its geometric patterns, its mechanical pulse, carrying answers to questions humanity wasn't ready to ask. Not yet. But soon. November 28th, 2025. There's a room you've never heard of. No press releases mention it, no official reports acknowledge it exists. It's not in any public database or government directory, but it's real. And on this cold November night, 7 people sit around a table inside that room, staring at data they wish they'd never seen. They're scientists, astronomers, physicists, some of the brightest minds in their fields, people who've spent their entire careers studying comets, asteroids, interstellar objects, people who understand how the universe works, or thought they did. The meeting was called quietly. No formal invitations, just encrypted emails, secure phone calls. "We need to talk. in person. Bring nothing digital. They gathered at a private research facility outside Pasadena, California, away from universities, away from government oversight, away from anyone who might ask questions, because the questions they were about to ask couldn't be asked in public. Dr. Sarah Chen from MIT sat at the head of the table. She'd been studying 3I Atlas since its discovery in July. She'd seen every anomaly, analyzed every data point, and she'd reached a conclusion she couldn't ignore anymore. She opened her laptop, pulled up a presentation. No title, just raw data. "We're not here officially," she began. Her voice was steady, but you could hear the tension underneath. "Nothing we discuss tonight gets published. Nothing gets reported. Nothing leaves this room." Everyone nodded. She clicked to the first slide. The light curve of 3I Atlas, the 11.3-second pulses, repeating with mechanical precision. "We've tried to explain this naturally," she said. "Rotation, surface features, optical effects, none of them work." Next slide, the thermal data, the impossible heat regulation. "We've tried outgassing, subsurface insulation, exotic ice compositions, none of them fit." Next slide, the geometric dust patterns, the arcs and spirals that shouldn't exist. "We've tried magnetic fields, pressure gradients, complex rotation states. Nothing produces this geometry." Next slide, the spectroscopic analysis. Nickel concentrations 50 times higher than normal, almost no iron. "We've tried unusual stellar environments. Chemical fractionation. Every exotic formation scenario we can think of. The ratio doesn't make sense." She paused. Let the weight of it settle. Then she said the thing no one wanted to hear. "So I ran a different kind of simulation. I asked a different question." She clicked to a new slide. A single sentence. "If 3I Atlas were artificial, what would its behavior look like?" The room went silent. Dr. Rajesh Kumar from Caltech leaned forward. "Sarah, I know," she said quietly. "I know what this sounds like, but just hear me out." She pulled up a simulation, a model she'd built over the past week, working alone in her office at 3 a.m., too afraid to share it with anyone. "I took all the data, the pulses, the heat curve, the dust geometry, the chemical composition, and I asked the computer, what kind of object would produce these exact signatures?" She hit enter. The simulation ran. And the model that came back wasn't a comet. It was something controlled, something with internal systems, something that pulsed because it had a mechanism generating the pulses, something that regulated heat because it had thermal management, something that arranged dust because it had a purpose. The fit was perfect, better than any natural model anyone had produced. Dr. Kumar stared at the screen. This can't be right. "I've run it 20 times, Dr. Chen said. "Different parameters, different assumptions. It keeps coming back to the same conclusion." Dr. Elena Vargas from Chile, the one who first spotted the pulses, spoke up. "Are you saying 3I Atlas is a probe?" "I'm saying the data fits that hypothesis better than any natural explanation we have." "That's insane. I know. We can't publish this." "I know." Another scientist, Dr. James Okonkwo from South Africa, rubbed his face. "If we even suggest this publicly, if we say the words artificial object, we'll be destroyed. Our careers, our reputations, everything." "I know," Dr. Chen said again. "That's why we're here. Not in a university, not in a government lab. Here, where no one's watching." For a long moment, no one spoke. Then Dr. Kumar asked the question they were all thinking. "What do we do?" Dr. Chen looked around the table. "We need to decide. Do we contact SETI? Do we alert space agencies? Do we go public? Or do we stay silent?" That question hung in the air like smoke, because there were consequences either way. If they went public and they were wrong, if 3I Atlas turned out to be a natural object with exotic but explainable properties, they'd be laughingstocks. The scientists who cried alien, who saw patterns where none existed, who let their imaginations run wild. But if they stayed silent and they were right, if 3I Atlas really was artificial, if it really was a probe from another civilization, if humanity's first contact with extraterrestrial intelligence happened and they said nothing, history would judge them harshly. Dr. Vargas spoke quietly. "We don't have enough proof. Not yet. The data is suggestive, but it's not conclusive." "Then what do we need?" Dr. Kumar asked. "More observation, more data. We need to watch what happens when it reaches Jupiter in November. That's 2 weeks away." "I know." Dr. Chen closed her laptop. "So here's what I propose. We keep watching. We keep analyzing. We share data privately among this group. And we wait. Wait for what? For 3I Atlas to do something that can't be explained away. Something undeniable. And if it does, then we go public. All of us. Together, we release everything." They agreed. A pact made in silence. A secret held by 7 people who knew they might be witnessing the most important discovery in human history, or the biggest mistake of their careers. As they left the facility that night, driving away in separate cars, heading back to separate cities, each of them carried the same weight. The weight of knowledge they couldn't share, the weight of a hypothesis they couldn't speak, and the weight of a question that wouldn't stop echoing in their mind. What if we're not alone? 3I Atlas continued its journey, silent, pulsing, geometric, chemical, heading toward Jupiter, and somewhere in the cold machinery of that strange visitor, something continued to function, continued to operate, continued to perform whatever it was designed to do, if it was designed at all. November 3rd, 2025. The message went out at 4:17 a.m. Greenwich Mean Time, encrypted, high priority, sent to every major observatory, space agency, and research institution on Earth. Most people were asleep when it arrived, but the ones who were awake, The astronomers on night shift, the mission controllers monitoring spacecraft, the researchers analyzing data in the quiet hours before dawn, they saw it immediately. And they stopped what they were doing, because the message came from NASA headquarters, from the Office of Planetary Defense, and it carried a designation that hadn't been used in over a decade, Observation Protocol Omega, reserved for objects of undetermined origin with potential non-natural characteristics. In simpler terms, things we don't understand, things that don't fit the rules, things that might not be natural. The protocol was created in 2014 after the Chelyabinsk meteor exploded over Russia and caught everyone by surprise. It was designed as a framework for coordinating global observation of potentially hazardous objects. But potentially hazardous usually meant asteroids on collision courses with Earth. It didn't mean interstellar visitors behaving strangely until now. Dr. Lisa Martinez, director of NASA's Near-Earth Object Program, had spent 3 days arguing with administrators before they finally agreed to activate the protocol. "This is unprecedented," one administrator had said. "We don't even know what we're looking at." "Exactly," Dr. Martinez replied. "That's why we need Omega." The protocol authorization came through late on November 2nd. By dawn on November 3rd, the message was out, and the global astronomy community went into high gear. At the Juno Mission Control Center in Colorado, engineers received a priority query: assess feasibility of trajectory adjustment for 3I Atlas intercept. Juno had been orbiting Jupiter since 2016, 9 years of operation. It had already completed its primary mission and was running on extended funding, studying Jupiter's atmosphere and magnetic field. But now someone wanted to know, could Juno be redirected to intercept an interstellar comet? The flight dynamics team ran the numbers, calculated the delta V required, assessed remaining fuel reserves. The answer came back within 6 hours. Feasible, but high risk. Redirection would terminate primary mission objectives and limit future maneuverability. In other words, yes, we can do it. But if we do, Juno's scientific mission at Jupiter ends. The decision was escalated to NASA's Science Mission Directorate, debated behind closed doors, weighed against competing priorities. Meanwhile, halfway around the world, the James Webb Space Telescope received new tasking orders. Webb, humanity's most powerful space observatory, launched in 2021 and positioned 1 million miles from Earth, had an observation schedule booked months in advance. Every hour of telescope time was precious, allocated to researchers, studying distant galaxies, exoplanets, stellar nurseries. But on November 3rd, that schedule was cleared. Priority target, 3I Atlas. Mission objective, continuous spectroscopic monitoring through Jupiter approach. Dozens of research teams whose observations had just been bumped sent urgent emails demanding explanations. They received a single reply: rescheduling due to time-critical solar system target. No further information available. On the ground, radio telescope arrays across the planet were repositioned. The Very Large Array in New Mexico, the Atacama Large Millimeter Array in Chile, the Meerkat Array in South Africa, all of them turning toward the same point in space. All of them listening. Officially, they were conducting routine observations of interstellar object 3I Atlas. Unofficially, they were listening for signals, just in case, because Observation Protocol Omega included a clause that most people didn't know about, a subsection added quietly in 2019 after the Oumuamua controversy. In the event an object exhibits potential non-natural characteristics, SETI protocols may be activated at the discretion of the coordinating authority. SETI, the search for extraterrestrial intelligence. The radio telescopes weren't just observing 3I Atlas, they were listening to it. At 11 a.m. EST November 3rd, every major astronomy institution received a second message. Shorter, more direct. All eyes on 3I. Do not publish observational data until clearance. Coordinate through secure channels only. No signature, no explanation. Just an instruction. Watch, but don't tell anyone what you're seeing. The media blackout was immediate. Researchers who'd been sharing preliminary findings on social media went silent. Preprint servers that usually posted new astronomy papers daily showed nothing about 3I Atlas. The public noticed, but only barely. A few astronomy enthusiasts on forums asked why no one was talking about the interstellar comet anymore. The answers were vague. Still analyzing data. Nothing new to report. Routine observations continuing. But behind the scenes, data was flooding in. Terabytes of it. Observations from dozens of facilities, spectroscopy, photometry, thermal imaging, radio monitoring, all of it funneled to a central coordination center. All of it classified. Dr. Martinez watched the data streams on her monitor. The pulses, still regular, still precise. 11.3 seconds. The thermal signatures, still regulated, still controlled. The dust geometry, still evolving, still geometric. And something new. Faint radio emissions detected by the Very Large Array. Not structured, not clearly a signal, but present, where there should be silence. She picked up her phone, called the 7 scientists who'd met in Pasadena 5 days earlier. "It's happening," she said quietly. 3I Atlas reaches Jupiter in 10 days, and we need to be ready for whatever comes next. "Ready for what?" Dr. Chen asked. "I don't know, but if this does something, if it activates or responds or changes behavior when it enters the Jovian system, we need to document everything. And if it does nothing, then we'll have our answer. It's just a strange comet, and we all go back to normal. But neither of them believed that. Not anymore. Because normal didn't pulse every 11.3 seconds. Normal didn't regulate its own temperature. Normal didn't arrange dust in geometric patterns or concentrate nickel to impossible levels. Normal was over, and whatever 3i Atlas was, humanity was about to find out. 10 days until Jupiter approach, 10 days until answers, or 10 days until everything changed. The telescopes watched, the spacecraft prepared, the data accumulated, and 3i Atlas, silent and strange, continued its journey through the dark, carrying secrets we were finally ready to face, or destroy us for discovering. November 1st, 2025. 13 days. That's all they had left. 13 days until 3i Atlas reached Jupiter. 13 days until the moment that would either answer every question they'd been asking since July, or create 1,000 new ones. Dr. Sarah Chen stood in the observation planning room at NASA's Jet Propulsion Laboratory in Pasadena, staring at a massive screen showing the trajectory of 3i Atlas. The glowing line curved through the solar system like a thread pulled through fabric, bending around the sun, arcing outward toward the giant planet that dominated the outer reaches of our cosmic neighborhood. December 13th. That was the date circled in red on every calendar, marked in every mission schedule, burned into the mind of every astronomer who'd been tracking this strange visitor since its discovery in July. The day 3i Atlas would pass through Jupiter's magnetosphere, that invisible bubble of charged particles and magnetic field lines extending millions of kilometers out from the planet. A cosmic trap, a natural laboratory where physics happened at scales we could barely comprehend, and where, if 3i Atlas was going to reveal its true nature, it would happen. We need every available telescope locked on that approach, Dr. Chen said to the team assembled around the conference table. Scientists from NASA, ESA, JAXA, mission controllers, data analysts, radio astronomers, people who'd dropped everything else in their professional lives to focus on this one event, because something was going to happen on December 13th. They all felt it, some nameless certainty that had nothing to do with data and everything to do with intuition. The kind of feeling astronomers learned to trust after decades of watching the sky. The pulses, the heat regulation, the geometric dust pattern, the impossible nickel chemistry that violated every model of natural comet formation. Every anomaly had been building towards something. And Jupiter was where it would all come together. Webb is cleared, Dr. James Okonkwo reported from his station. Full spectroscopic suite ready. We'll have continuous coverage from approach through departure. High sensitivity across infrared and near-infrared bands. Hubble, scheduled and confirmed, another voice called out. High-resolution imaging every 6 hours. We're prioritizing Europa and Ganymede positions during the encounter window. Ground arrays? VLA in New Mexico is repositioned. ALMA in Chile is locked on target. Meerkat in South Africa standing by. All radio monitoring at full sensitivity. If 3i Atlas emits anything, radio, microwave, anything electromagnetic, we'll detect it. Dr. Chen nodded slowly, but the knot in her stomach didn't loosen. It wasn't enough. It was never enough, because they still didn't know what they were preparing for. Was 3i Atlas just a comet? Strange, yes. Unusual, definitely. Pushing the boundaries of what we understood about interstellar visitors. But ultimately natural? A product of exotic formation conditions in some distant star system we'd never see? Or was it something else entirely? She thought about the secret meeting 3 weeks ago. 7 scientists in an unmarked facility outside Pasadena. The simulation that Dr. Chen had run privately, in the dark hours of the morning when doubt whispered loudest. The simulation that showed artificial behavior fitting the data better than any natural model they'd produced. The hypothesis they couldn't speak out loud. Not in official reports. Not in peer-reviewed papers. Not in any forum where careers could be destroyed by speculation that sounded too much like science fiction. What if 3i Atlas was designed? What if the pulses weren't a natural byproduct of rotation or outgassing, but something generated, something controlled? What if it was heading toward Jupiter not because of random gravitational dynamics, but on purpose? What if December 13th wasn't just a flyby, but an arrival? Dr. Rajesh Kumar from Caltech stood and walked to the screen. We've run over 200 simulations in the past week. Different initial conditions, different assumptions about mass, composition, trajectory, trying to predict what happens when it enters the magnetosphere. And, Dr. Chen asked, though she'd seen most of the results already, 3 main scenarios keep appearing. He pulled up a visualization showing 3i Atlas's path through Jupiter's magnetic field. First, standard flyby. The object passes through, maybe sheds some dust from electromagnetic interactions, experiences some heating from charged particle bombardment, but fundamentally continues on its outbound trajectory. We get excellent observational data, but nothing that would resolve the anomalies we've already documented. Probability? Someone asked. Hard to say definitively. Maybe 40%? It's the null hypothesis, the boring answer. What's scenario 2? Gravitational or electromagnetic capture? Kumar switched to a different visualization. If it's moving slowly enough, and our velocity measurements have some uncertainty, or if Jupiter's magnetic field interacts with its composition in ways we don't fully understand, it could be pulled into orbit, temporarily at least, maybe permanently. That would give us months to study it, Dr. Elena Vargas said from across the room. Exactly. Extended observation time, close-range analysis. We could potentially redirect Juno to intercept it if it enters a stable orbit. What's the third scenario? Dr. Chen already knew, but she needed everyone in the room to hear it. Kumar's expression darkened slightly. Fragmentation. Tidal forces could tear it apart as it passes through periapsis. We saw this with Comet Shoemaker Levy 9 back in 1994. If the nucleus is loosely bound, if it's more rubble pile than solid rock, Jupiter's gravity could rip it into pieces. The room went quiet for a moment, because fragmentation meant spectacular images, it meant impact events, it meant scientific data they'd analyzed for decades, but it also meant losing the object, destroying whatever answers it might have provided. If it fragments, Vargas said carefully, some pieces could impact the moons. Europa, Ganymede, Callisto. Yes, Kumar confirmed. We'd have direct material deposition, which from an astrobiological perspective might be, he trailed off, because interesting wasn't the right word for what it would mean if interstellar material carrying complex organics impacted Europa directly. It would be terrifying, and extraordinary, and impossible to predict the consequences of. Dr. Chen stared at the 3 simulations cycling on the screen. All natural, all based on known physics, all within the realm of possibility, but none of them accounted for the anomalies they'd already witnessed. None of them explained the pulses that continued with mechanical precision, the heat regulation that looked more like engineering than geology. What if it does something else? She asked quietly. Something we're not predicting? Every head in the room turned toward her, because that was the real fear. Not that 3i Atlas would behave naturally, but that it would behave intentionally. If the pulses change, Vargas said slowly. If the frequency accelerates or if they stop entirely, if the thermal signature spikes beyond what solar heating or electromagnetic interactions can explain, if we detect emissions at specific frequencies that suggest directed transmission, then we'll know, Dr. Chen finished. One way or another, we'll know what we're dealing with. But knowing came with consequences that nobody wanted to articulate. If 3i Atlas turned out to be artificial, if it activated, responded, transmitted, the world would change overnight. No more secrets, no more classified protocols, no more quiet analysis behind closed doors. The truth would be undeniable, recorded by dozens of independent observatories, verified by hundreds of scientists across multiple countries, and humanity would have to face the reality that had haunted philosophers and scientists for centuries. We are not alone. Dr. Chen looked at the countdown clock mounted on the wall. Digital red numbers ticking down with merciless precision. 12 days, 18 hours, 34 minutes until Jupiter encounter. 13 days to prepare. 13 days to position every instrument humanity possessed. 13 days to coordinate observation schedules across time zones and international boundaries. 13 days to brace for whatever came next. Outside the JPL building, beyond the thick walls and security checkpoints, the world continued its normal rhythm. People commuted to work through Los Angeles traffic. Students attended classes at nearby universities. Families planned Thanksgiving dinners. Life moved forward like nothing extraordinary was about to happen. But inside this room, a small group of scientists carried a weight that no one else could feel. The weight of anticipation. The weight of waiting for a moment that might rewrite everything we thought we knew about our place in the cosmos. The weight of knowing that in less than 2 weeks, an object from another star system would pass through Jupiter's domain. And whatever happened during those hours would echo through history. All stations confirm readiness status by November 10th, Dr. Chen said, her voice steady despite the chaos of thoughts churning beneath. No delays. No technical excuses. When that object crosses into Jupiter's magnetosphere, I want every telescope, every radio dish, every spectrometer we have pointed at that region of space. And if something happens, a young researcher asked from the back of the room. If it does something we can't explain, Dr. Chen met his eyes, saw the mixture of excitement and fear that she felt herself. Then we document everything. We record every data point. We follow the protocols. And we deal with the consequences, whatever those consequences might be. 13 days. The clock kept counting down. Time moved forward. December 13th approached like an inevitable tide. And somewhere in the dark between Earth and Jupiter, 3i Atlas continued its journey, pulsing, regulating, carrying its secrets toward a moment that 7 billion humans knew nothing about, but would change everything. November 5th, 2025. The models kept running. Day and night, computer simulations consuming processing power across multiple institutions, trying to predict what would happen on December 13th when 3i Atlas entered Jupiter's magnetosphere, trying to answer the question everyone was asking but no one wanted to say out loud. What if 3i Atlas does something we can't explain? Dr. Sarah Chen sat in her darkened office at JPL at 2:17 a.m., watching simulation after simulation play out on her dual monitors. The building was quiet at this hour. Just the hum of air conditioning and the soft glow of emergency exit signs in the hallway. But her mind was loud, racing, unable to rest. She pulled up the latest probability analysis, charts and graphs, showing different scenario outcomes based on varying input parameters. Scenario 1, natural comet behavior. 3i Atlas passes through Jupiter's magnetosphere, experiences electromagnetic heating, maybe brightened slightly from particle interactions, sheds some dust, then continues outbound toward the outer solar system and eventually back to interstellar space. The boring answer, the safe answer, the one that kept everything we understood about the universe intact. Probability, 40%. Scenario 2, Fragmentation. Tidal forces from Jupiter's immense gravity overcome the structural integrity of the nucleus. The object breaks apart into multiple pieces. Some fragments impact Jupiter, creating spectacular atmospheric disturbances. Others scatter through the Jovian system, possibly impacting the moons. Dramatic, destructive, but still natural. Probability, 25% scenario. 3. Temporary orbital capture. The object's velocity and trajectory align just right with Jupiter's gravitational field. Instead of slingshotting past, it's captured into an elliptical orbit. Temporary at first, maybe lasting months or years before being ejected again. The best case scenario for science, extended observation time. Close range analysis, probability, 15%. And then, the scenarios that didn't appear in any official report. The ones Dr. Chen modeled privately. The ones that kept her awake at night. Scenario 4. Behavioral change. The pulses that have maintained 11.3 second intervals since early November suddenly change, accelerate, decelerate, stop entirely, or form new patterns, suggesting the object is responding to its environment, reacting to Jupiter's proximity in ways that imply awareness. Probability, unknown, unquantifiable, dependent on factors we don't understand. Scenario 5. Enhanced thermal activity. Temperature regulation becomes more pronounced. The object actively manages internal heat in ways that can't be explained by passive thermal properties or natural outgassing, like something with an internal power source. Probability, unknown. Scenario 6. Electromagnetic transmission. Radio emissions, signals, broadcasts at specific frequencies that suggest structure and intention. The nightmare scenario, the one that would change everything. Probability, unknown, but if it happened, undeniable. Dr. Chen stared at that last scenario. The words seemed to pulse on her screen in rhythm with her heartbeat. What if 3i Atlas spoke? Not metaphorically, not through its chemistry or behavior or trajectory, but actually transmitted, broadcast, announced itself to anyone listening. The SETI community had spent decades searching for exactly that. Radio telescopes pointed at distant stars, listening for signals from civilizations thousands or millions of light years away, some faint whisper of intelligence in the cosmic static. But what if the signal didn't come from some impossibly distant galaxy? What if it came from right here, from our solar system, from an object that had traveled across light years specifically to deliver a message directly to us, or not to us? To Jupiter, to Europa, to whatever target it was actually aimed at. She pulled up the data they'd already collected. The 11.3 second pulses visible in photometric observations from multiple telescopes. The light curve showing that mechanical precision, that artificial rhythm. The graph looked like a heartbeat on a medical monitor. Steady, regular, unchanging. But what if it changed on December 13th? What if the pulses accelerated as 3i Atlas entered the magnetosphere? What if they formed patterns, mathematical sequences, prime numbers, something that screamed intelligence? What if the object had been dormant during its passage through the inner solar system, conserving energy, maintaining minimal function, and Jupiter was the trigger to wake it fully? Her phone buzzed on the desk. A message from Dr. Elena Vargas. Can't sleep either? Call me if you're awake. Dr. Chen dialed immediately. Vargas picked up on the first ring. I've been running signal analysis protocols all night, Vargas said without preamble, her voice thick with exhaustion, preparing for every possible frequency range. If 3i Atlas transmits anything, radio, microwave, millimeter wave, anything electromagnetic, we'll detect it within seconds. Every major radio telescope on Earth will be pointed at Jupiter. And if it does transmit, Dr. Chen asked, if we get a clear signal that can't be explained naturally, silence on the other end. Then we'll have maybe 6 hours before the media finds out. Probably less. Someone will leak. Someone always leaks. You can't keep something that big secret when hundreds of scientists across dozens of institutions all see the same data simultaneously. Dr. Chen closed her eyes. Tried to imagine those 6 hours. The frantic verification, the emergency meeting, the desperate attempts to understand and contextualize before the world learned what had happened. 6 hours between first contact and global awareness, between scientific discovery and civilizational shift. Are we ready for that? She asked quietly. No one's ready for that, Vargas replied. You can't be ready for the moment everything changes. You just experience it, deal with it, try not to let it break you. They talked for nearly 2 hours. About observation protocols, about data handling procedures, about who they'd call first if the impossible happened, about what they'd say when asked to explain what they'd witnessed. But mostly they talked about fear, the kind of existential fear that came from standing at the edge of a precipice and knowing you were about to jump whether you wanted to or not. Fear that they were wrong, that they'd let their imaginations overwhelm their scientific discipline, that December 13th would arrive and 3i Atlas would just pass by like any other comet. Strange, yes, unusual, certainly, but ultimately explicable. And they'd look like the astronomers who, cried Alien, who saw artificiality in natural phenomena, who let hope or fear or excitement cloud their judgment. Their careers would survive, but the embarrassment would linger, the whispers in conference hallways, the knowing looks from colleagues. But there was another fear, deeper, more profound, more terrifying in its implications. Fear that they were right, because if 3i Atlas was artificial, if it was a probe or vessel or machine sent by intelligence from another star system, then everything humanity believed about its place in the universe would shatter like glass. We wouldn't be alone anymore. wouldn't be unique, wouldn't be the pinnacle of evolution or the universe's greatest achievement. We'd just be one civilization among others. Maybe many others, maybe countless others spread across the galaxy, building things, sending things, exploring things, and we'd have to face questions we weren't prepared to answer. Why did they send it here? What were they looking for? What did they find? Are they still out there watching, waiting for our response? Or are they long gone, extinct, vanished, leaving only their machines to wander forever between the stars? Dr. Chen thought about Europa, Jupiter's ice-covered moon hiding its ocean beneath kilometers of frozen crust. The most promising place in the solar system to search for life beyond Earth? What if that was the actual target? What if 3I Atlas wasn't aimed at Jupiter for gravitational assistance or scientific curiosity about gas giant magnetospheres? What if it was aimed at the moons, at Europa specifically? What if it's carrying something? She said suddenly, breaking a long silence on the phone. What if the goal isn't to study us or even observe the solar system? What if it's delivering something to Europa? Vargas was quiet for a long moment. Like panspermia? Like the old hypothesis about comets spreading life. Like directed panspermia, Dr. Chen clarified. Not random, intentional. A courier carrying the chemistry of life, delivering it to worlds where conditions are right, where it might actually take root and grow. Vargas paused. That's a huge conceptual leap, Sarah. I know, but look at everything we found. The nickel chemistry that doesn't exist in natural comets. The complex organic molecules we're detecting in the dust. The geometry of the coma suggesting controlled distribution of material. What if all of that isn't evidence of artificial construction in the sense of a probe or spacecraft? What if it's evidence of biological cargo, chemistry specifically selected and preserved for delivery? And then what? We just watch as interstellar material potentially contaminates the most astrobiologically interesting moon in the solar system? Maybe it's not contamination, Dr. Chen said slowly, working through the idea as she spoke. Maybe it's gardening. Maybe that's what advanced civilizations do. They don't conquer worlds or establish colonies. They plant gardens. They spread the chemistry of life to places where it can flourish. And then they wait. Centuries, millennia, millions of years, just waiting to see what grows. The word hung in the air between them. Gardening. Such a simple, earthly word for something so cosmically profound. 8 days, Vargas said finally, her voice barely above a whisper. 8 days until we find out if we're insane or prophetic. Yeah, Dr. Chen agreed. 8 days. Get some sleep, Sarah. You'll need it. You too, Elena. But neither of them would sleep. Not tonight. Not with the weight of possibility pressing down on them. Not with December 13th approaching like an inevitable collision. 8 days until 3I Atlas reached Jupiter. 8 days until every telescope on Earth watched a single point in space. 8 days until they learned whether humanity was truly alone in the universe, or whether we'd always been part of something larger, something ancient, something patient, something that had been gardening the galaxy long before humans existed to notice. Dr. Chen closed her laptop, sat in the darkness of her office, listened to the building's quiet nighttime sounds, and waited for dawn, for another day closer to December 13th, another day closer to answers, or to more profound questions than anyone had dared to ask before. November 8th, 2025. 5 days. Dr. Amara Ose sat in her office at the European Space Agency's Astronomy Center in Madrid, staring at high-resolution images of Europa displayed across 3 monitors. The ice-covered moon filled her screens in breathtaking detail. White and pristine, like fresh snow, crisscrossed with reddish-brown fractures where tectonic forces had cracked the frozen surface like a shattered mirror. Beautiful. Ancient, hiding secrets beneath that ice that humanity had wondered about for decades. Beneath that frozen shell, 15 to 25 kilometers down, an ocean, a global ocean of liquid water, kept warm and mobile by tidal heating from Jupiter's immense gravitational pull. As Europa orbited the giant planet, Jupiter's gravity squeezed and released the moon rhythmically, generating friction, producing heat, melting ice that should have been frozen solid this far from the sun. And in 5 days, 3I Atlas would pass close enough to potentially deposit material onto that ice, to leave its mark, to deliver whatever cargo it carried from another star system. Dr. Ose had been running trajectory models for the past week, complex simulations showing how Jupiter's magnetosphere would capture and distribute particles shed from 3I Atlas during its passage. Dust grains, complex molecules, whatever material the comet released as it encountered the intense electromagnetic environment surrounding the giant planet. The mathematics were clear, unambiguous. If 3I Atlas released material, and comets always released material when passing through magnetic fields that strong, some percentage of that dust would be captured by Jupiter's gravitational and magnetic fields, sorted, distributed, scattered throughout the system, and some of it would end up on Europa, maybe on Ganymede too, the largest moon, orbiting further out, maybe scattered across Callisto's ancient crater-scarred surface, maybe deposited in thin layers across all the major moons. But Europa was special. Europa was different. Because Europa had everything life needed, everything except possibly the spark, the initial organic molecules that could jumpstart biological processes, the chemistry that could bridge the gap between complex organic compounds and actual living systems, and 3I Atlas was carrying those molecules. They detected them in the spectroscopic analysis. Carbon chains, nitrogen compounds, the building blocks that, given the right environment, might assemble into something more. Dr. Osi pulled up the spectroscopic data again. She'd reviewed it so many times she could recite the emission lines from memory. The nickel signature that was 50 times stronger than any natural comet. The complex carbon compounds showing patterns that suggested long-chain molecules. The chemical signatures that didn't quite match anything in their databases of solar system objects. What if that chemistry wasn't accidental? What if it was designed to survive? To remain stable and viable through millions of years of interstellar travel? To be deposited on worlds like Europa where conditions were right for something to happen? She'd written a report 3 days ago. 27 pages of analysis, modeling, and carefully worded speculation. She'd marked it preliminary analysis, internal review only, and sent it to the Europa mission planning team at NASA. The response had come back within 18 hours. Polite, professional, deeply cautious. Dr. Ose, thank you for this interesting hypothesis. Your trajectory modeling is excellent and will certainly recommend monitoring Europa's surface for any post-encounter deposits. However, we would caution against over-interpretation of preliminary spectroscopic data. Many of these signatures could have natural explanations we haven't fully explored yet. Recommend additional analysis before making stronger claims. Europa Science Team. Translation. Fascinating idea. Don't say it out loud where anyone important might hear you, because if 3i Atlas really was delivering organic material to Europa intentionally, if this was some kind of interstellar seeding mission, deliberate and targeted, the implications went far beyond interesting science. It would mean life didn't necessarily originate independently on every world. It could be spread, distributed, carried between star systems by mechanisms natural or artificial. It would mean the galaxy might be more interconnected than we'd ever imagined. Not through radio signals or starships or interstellar empires, but through something subtler, something patient, something that operated on timescales measured in millions of years. Gardening. That's what Dr. Chen had called it in their last conversation. Cosmic gardening. Spreading seeds that might or might not take root. Planting gardens on worlds with the right conditions, and then waiting for evolution to work, for chemistry to become biology, for gardens to bloom in their own time. And if Earth itself had been seeded this way 4 billion years ago, when our planet was young and sterile, then we weren't the first garden. We were just one of countless gardens scattered across the galaxy. Some flourishing, some failing, some just beginning. All part of a process that spanned the cosmos and predated anything humans had built or dreamed. Dr. Ose zoomed in on Europa's equatorial region, the area where 3i Atlas's trajectory would bring it closest to the moon, where the probability of dust deposition was highest according to her models. If material settled there, if it landed on the ice in concentrations high enough to detect from Earth-based telescopes or orbital observations, they'd eventually find it, maybe not immediately. The deposits would be thin, micrometers, barely more than a frost, but they'd be there, carrying a chemical signature that matched 3i Atlas, carrying organics that didn't form naturally on Europa, carrying possibly the ingredients for life. And then what? What would they do with that knowledge? How would they respond to the discovery that interstellar material had contaminated, or enriched, the most astrobiologically promising location in the solar system? She pulled up geological models showing how Europa's surface evolved over time. The ice wasn't static, it moved, cracked, shifted. Tidal forces from Jupiter flexed the moon continuously, creating stress patterns that fractured the crust and allowed material exchange between the surface and deeper layers. The models showed geological processes working over years, decades, centuries. Surface material gradually working its way down through fractures, carried by temperature gradients, by pressure differences, by the slow churning of Europa's active ice shell. Eventually, maybe in 100 years, maybe in 1,000, some of that surface material would reach the ocean, would melt through the final layers of ice and mix with liquid water, carrying whatever chemistry it had accumulated on the surface, including possibly interstellar organics from 3i Atlas, molecules that had traveled light years, that had survived radiation and cold and time, that had been delivered to this specific moon for reasons we might never fully understand. What would happen then, when those molecules reached Europa's ocean? When they mixed with water and minerals and whatever chemistry already existed in that dark sea, would they dissolve harmlessly? Just more organic compounds in an environment already rich with carbon chemistry? Or would they catalyze something? Provide the missing piece in some chemical puzzle? Serve as templates or building blocks for processes that couldn't start without them? Would Europa's ocean, given this influx of interstellar chemistry, begin the long, slow process of abiogenesis, the emergence of life from non-living matter? Dr. Ose saved her analysis, encrypted the files with 3 layers of security, backed everything up to multiple secure servers, because 5 days from now, when 3i Atlas passed through Jupiter's magnetosphere, someone needed to be watching Europa carefully. Not just watching for the spectacular, not just tracking the comet or monitoring for signals, but watching the quiet recipient of whatever delivery was being made. She composed another message, this one to Dr. Sarah Chen at JPL. Dr. Chen, please ensure Hubble imaging includes high-resolution observations of Europa throughout the December 13th encounter. Multiple wavelengths, particular attention to the equatorial regions on the trailing hemisphere. We need to document any material deposits in real time if possible. The implications for astrobiology could be significant. Dr. Osei. The response came back within 10 minutes. Dr. Osei, already in the observation plan. Hubble will have Europa in frame throughout the passage window. Multiple exposures, full spectroscopic coverage. If anything deposits on that ice, we'll catch it. Chen. Good. That was good. Because if this was a delivery mission, if 3I Atlas really was a gardener, a courier, a mechanism for spreading life's chemistry across the vast distances between stars, then Europa was the garden, the target, the recipient, the carefully selected world where conditions were right for something extraordinary to begin. And 5 days from now, the delivery would be made. The seeds would be planted. The garden would receive its gift from the stars. Whether humanity understood what was happening or not, whether we recognized the significance or dismissed it as random chance, the universe didn't require our understanding. It didn't wait for our permission. It just continued its ancient processes. Patient. Inevitable. Working on scales that made human lifetimes look like heartbeats. Dr. Osei looked at the images of Europa one more time. That beautiful, mysterious moon hiding its ocean. Waiting. Always waiting. In 5 days, it would wait no longer. The garden would receive its seeds. And in the dark water beneath that ice, chemistry would begin to shift, to change, to move towards something that might, in time, become life, or might not. The universe made no guarantees. It only offered possibilities, opportunities, gardens where something might grow if conditions aligned. 5 days. Europa waited, patient, silent, ready. And somewhere between Earth and Jupiter, 3I Atlas continued its journey, carrying its cargo, approaching its destination, counting down to the moment when millions of years of travel would culminate in a delivery that might be the most significant event in the history of life in our solar system. If anyone was paying attention, if anyone understood what they were about to witness. November 10th, 2025. 3 days. Dr. Sarah Chen stood on the roof of Griffith Observatory in Los Angeles, watching the sun sink toward the Pacific horizon. The sky burned orange and red, casting long shadows across the city spread out below. Millions of lights beginning to flicker on as darkness approached. The vast sprawl of Los Angeles preparing for another evening. Traffic, dinner, television, the ordinary rhythm of human life. 3 days until December 13th. 3 days until everything might change. She leaned against the railing, feeling the cool metal through her jacket, and thought about the journey that had brought them to this moment. From July 1st, when a faint smudge appeared in images of the constellation Aquarius, when astronomers had logged it as just another interstellar visitor. The third one confirmed. Mildly interesting, but probably not exceptional. Through perihelion in late October, when 3I Atlas should have blazed with activity as it passed close to the sun, when every comet model predicted brilliant outgassing and magnificent tails, when instead it went quiet, dimmer than it should have been, silent when it should have been screaming, through all the anomalies that followed, each one small enough to dismiss individually, each one strange enough to demand explanation, but together they wove a pattern that couldn't be ignored. The pulses, 11.3 seconds of mechanical precision, like something designed, like something artificial. The heat regulation, absorbing energy when it should be radiating, staying warm when it should be freezing. Temperature curves that looked more like engineering than geology. The geometry of the dust, arcs and spirals and repeating patterns that shouldn't exist in natural outgassing. Structure that suggested control, design, purpose, and the chemistry, the nickel concentrations that violated every model of comet formation, the absence of iron that should have been there, the organic molecules that hinted at complexity we couldn't fully analyze from this distance, each anomaly explainable on its own maybe, with enough creative physics and exotic assumptions, but together they told a story about an object that didn't quite fit, that behaved just slightly wrong in too many ways, that seemed to have a destination rather than just a trajectory, and now it was heading toward Jupiter, approaching the giant planet's gravitational and electromagnetic embrace, and in 3 days, they would all watch what happened next. Her phone buzzed. A message from the Mission Coordination Center. Final status check complete. All observatories reporting ready. Webb locked on target. Hubble standing by. Ground arrays positioned and calibrated. Radio monitoring at maximum sensitivity. Juno spacecraft queried and prepared for possible trajectory adjustment if needed. Protocols active. We are as prepared as we can be. Mission control. Prepared. The word felt hollow, inadequate. How do you prepare for a moment that might rewrite history? How do you prepare for the possibility that everything you thought you understood about humanity's place in the universe might be wrong? You don't. You just watch. You point your instruments at the sky and you record what happens. And then you deal with the aftermath, whatever that aftermath might be. Dr. Chen looked up at the darkening sky. Jupiter was visible tonight, rising in the southeast, a bright point of unwavering light, steadily climbing above the horizon as Earth's rotation brought it into view. To the naked eye, just another planet, one of 5 visible without a telescope, something humans had watched since the dawn of consciousness. But through a telescope, through the instruments that would be watching in 3 days, Jupiter became something else, a complex system, a miniature solar system with its own family of moons, an electromagnetic powerhouse with a magnetosphere that extended extended millions of kilometers into space, and somewhere between Earth and that bright point of light, invisible to even the most powerful telescope without knowing exactly where to look, 3i Atlas was traveling, moving at tens of kilometers per second, pulsing every 11.3 seconds, regulating its temperature, carrying its mysterious chemistry toward Jupiter's domain. Was it aware? Did it know where it was? Did it have consciousness or purpose or mission parameters programmed into whatever mechanisms drove its behavior? Or was it just a rock, ice and dust and coincidence, natural but exotic, strange but ultimately explainable? In 3 days they might know, or they might not. Because even if 3i Atlas did something extraordinary, even if it transmitted, activated, revealed itself as unambiguously artificial, there would still be so many questions left unanswered. Where did it come from? What star system birthed it or built it? What civilization, if any, sent it on this journey? How long had it been traveling? The trajectory calculation suggested millions of years. Maybe tens of million, an almost incomprehensible span of time, longer than human civilization had existed, longer than our species had walked the Earth. And why Jupiter? Why our solar system? Were we chosen? Targeted for some specific reason? Or just convenient? A star system that happened to have the right configuration of planets and moons? The questions spiraled endlessly. Each answer would spawn 10 more questions, a fractal of uncertainty spreading out in every direction. But underneath all of them, supporting all of them, was one fundamental question that mattered more than any other. Are we alone? December 13th wouldn't answer that question completely. Even if 3i Atlas turned out to be artificial, even if it was a probe or vessel or machine built by intelligence, it still wouldn't tell them where its makers were, whether they still existed, whether they were watching, whether they'd sent thousands of others like it throughout the galaxy. But it would be a start, a crack in the wall of cosmic silence that had surrounded humanity since we first developed the technology to listen. A single data point that would transform speculation into knowledge. We would know with certainty that intelligence existed beyond Earth, that we weren't the only minds that had looked up at the stars and wondered, that somewhere, somewhen, something else had reached the same conclusions we had developed technology, had built things, had sent those things out into the dark to explore or observe or deliver. Dr. Chen thought about Europa, about Dr. Osei's careful analysis, about the trajectory model showing how dust from 3i Atlas would be captured and distributed by Jupiter's magnetosphere, how some of that dust almost certainly would settle onto Europa's ice. What if we weren't the primary audience? What if this event, this extraordinary cosmic moment, wasn't aimed at humanity at all? We might just be witnesses, observers of a process that had nothing to do with us, a delivery system operating on principles and purposes we could barely comprehend. 3i Atlas might not be a message for us. It might not be meant to contact us or teach us or warn us. It might simply be doing what it was designed to do, traveling between star systems, finding worlds with the right conditions, depositing its cargo where that cargo could be used. Gardening, cosmic gardening on scales of time and distance that made human endeavors look like a child playing in a sandbox. And Europa, with its hidden ocean, its tidal heating, its energy sources, and chemical complexity, was the garden, the carefully selected location where seeds from another star could be planted, where chemistry from another system could mix with local conditions and potentially eventually become something more, become life. There was something profound about that possibility, something that shifted humanity's position in the cosmic narrative. We weren't the center of the story. We weren't the protagonists. We were just witnesses, observers of an ancient process that had been unfolding long before we existed and would continue long after we were gone. But maybe that was okay. Maybe there was something liberating about realizing that the universe didn't revolve around us, that greater forces were at work, that life might be common, distributed, seeded throughout the galaxy by mechanisms we were only now beginning to detect. If Earth itself had been seeded this way, 4 billion years ago, when our planet was young and molten and hostile to life, then we weren't separate from this process. We were part of it, products of it, evidence that it worked. Maybe we weren't the first garden. Maybe we were just one of countless gardens scattered across the Milky Way, some successful, blooming with life and complexity. Some failed, remaining barren. Some still in their infancy, just beginning the long chemical journey toward biology. All connected, all part of a galactic ecosystem that predated stellar astronomy and would outlast any single civilization. Dr. Chen checked her watch. 6:51 p.m. Pacific time. In 3 days, almost to the hour, 3i Atlas would enter Jupiter's magnetosphere, and every telescope humanity possessed would be watching, recording, documenting, waiting to see what happened when an interstellar visitor reached its destination, when a journey of millions of years culminated in a delivery, when seeds from another star were planted in a garden that had been waiting since the solar system formed. She whispered a question into the gathering darkness, the same question she'd been asking for months, the same question that haunted her dreams and consumed her waking thoughts. What are you? The stars didn't answer. They never did. Their light traveled for years across the void, carrying no messages, revealing no secrets, just photons arriving faithfully, marking the positions of distant suns. But in 3 days, maybe one of those visitors would answer. Maybe 3i Atlas would reveal itself. Maybe it would transmit or activate or simply do something so undeniably artificial that all debate would end. Or maybe it would pass silently, deposit its dust, continue outbound toward the outer solar system, and eventually back to interstellar space, leaving humanity with data but no conclusions, with observations but no certainty. Either way, the moment was coming, inevitable as sunrise, approaching like a tide that couldn't be stopped or slowed. 3 days. The garden waits, patient, silent, ready for whatever delivery approaches. Europa orbits Jupiter. Ice covering water, water covering possibility. An ocean that has waited for 4 billion years, that might wait billions more, or that might soon receive something that begins to change everything. And humanity watches, telescopes pointed at the sky, instruments calibrated and ready, scientists holding their breath across multiple continents and time zones, waiting to witness something that might be ordinary, or might be the most significant moment in the history of life in our solar system, waiting to learn whether we're alone, or whether we've always been part of something larger, something older, something that connects the galaxy in ways we're only beginning to glimpse. 3 days. The clock counts down. Time moves forward. December 13th approaches with the certainty of gravity, and somewhere in the dark between Earth and Jupiter, a 3-eye atlas continues its journey, pulsing, regulating, carrying secrets we might never fully understand, carrying seeds to a garden that waits beneath the ice, carrying answers we're finally ready to ask questions about. 3 days.